And we're live. Hello, everyone. Welcome here today, this morning, this evening, this afternoon, wherever you're tuning in from. We have a great group online already, so we thought we'd ask everyone where you are tuning in from. Let us know in the chat there. Excellent. Well, thank you so much, everyone, for tuning in today with us from all over the world. Today, I'd love to welcome you to our webinar, Bridging Between CAD and GIS, 6 Ways to Automate Your Data Integration. Today, I'm joined by both Evie and Sarah, so I'll hand it over to Evie to introduce herself.
Yeah, hi, I'm Evie. I work at Safe Software in technical support. I specialize in FME form, and I'm happy here to lead you in this webinar. I'll pass it on to Sarah.
Thanks. So hi, everyone. I'm Sarah, and I am also a technical support specialist at SAFE, also on the FME Forms side. I'm actually on the same team as Evie, and I'm also really excited to be here to talk about CAD and GIS with you all today.
Fantastic. Thank you both. And just a quick overview of our agenda. So we're going to be going through an overview of the topic today. Then we'll be going into migrating CAD drawings to GIS, challenges there, and then specifically with coordinate systems, labeling, and schema drift, which are common ones. Real world solutions we'll be demonstrating through some demos as well. Then we'll move on to sharing GIS data with CAD users, challenges, styling, and data requests specifically, and also real world solutions and demos on that subject. Then we'll have a conclusion with some resources to help you get started and our Q&A session. If you are new to Livestorm and you have any audio issues or video issues at all, you can click the help button on the bottom left for 4 simple troubleshooting steps. Share your emoji reactions with us during the webinar on the bottom middle there of your screen. We love to see them and see your reactions throughout. We really appreciate those. Great, people are testing it out already. We will have a poll shortly on the bottom right, so keep an eye on that polls tab. As I just mentioned, questions. Any questions throughout, drop them in. We'll keep an eye on that and then have the live Q&A at the end. And keep letting us know where you're tuning in from in the chat. All right, so here is our poll already. I will publish that. You should all see it under the polls tab. We'd love to know today, what do you see as the biggest challenges in CAD to GIS and vice versa data integration? A few options there, and if there are any other challenges that you face as primary ones, please put those in the chat. We'll give everyone a moment there. All right. It looks like the majority of votes have come in now. So I'll get our presenters. You can head on over to the polls tab and click the little eye emoji on the bottom right. And we can take a look at the results there together. It looks like translating geometry and attributes is a big one. Preserving annotations and symbology.
Oh yeah, those are the 2 winning ones for sure.
Someone in the chat said all of the above. All right, thanks so much, everyone, for voting there. We'll definitely aim to address any challenges today and provide some awesome tips and tricks for you along the way. All right, and with that, I will hand things over to Sarah to introduce us to our topic today.
All right, thanks, Elizabeth. Just give me 1 second here.
And while Sarah's starting her screen share here, I'll actually get our presenters to turn off their webcams, and that'll help us save on some bandwidth.
Thank you, Elizabeth. Just to continue a little bit with our webinar introduction here, thought we could start with just a broad look at what you can expect today. So this sentence here really summarizes our focus for our webinar today. We'll be exploring how you can use FME to overcome some of the challenges that you might encounter when trying to move from CAD to GIS and vice versa. And so thank you all for chiming in with the poll there. It kind of gives us an idea of what we should be showing. Right, so let's just talk really quickly about CAD versus GIS. Obviously, there are quite a few differences. For one thing, CAD users are focused on more on the drawing side and how things look, rather than, for example, what attribute data are attached to them. So symbologies, levels, layers, dimensions, these are all very visual elements and really important to get right in floor plans and building layouts. This can be compared to GIS users who tend to worry more about the features and information that their data can provide. So attributes, geometry tables, of course, location, these are kind of the important pieces here, since without them you can't really reliably do spatial analysis. So now I'm going to tell you a little bit more about our company, Save Software, so that you can get to know us a little better, especially if this is maybe your first webinar with us. We've been around for almost 30 years now, and in that time we've helped over 200,000 users all over the world solve their data challenges. We also have many global partners and a very, very friendly FME community, which is where you'll find our forums. We always encourage people to check that out if you haven't already. And this is our FME platform. So starting on the left there, FME Form is the authoring environment where you build your workflows. It has a visual drag and drop interface, and you will be seeing a lot of that today because this is the main part of the platform that we will be showing off in this webinar. On the right side there, we have FME Flow, and I like to think of this as the tool that takes your FME Form workflows to the next level. So you can do automations, schedules, triggers. There are lots of options to play around within there. And this can be deployed on premises or in your private cloud. And last but not least, we have FME Flow hosted. It's the same thing as FME Flow, but the infrastructure is managed by us here at SAFE in an AWS cloud environment. This nice graph here just kind of shows how far we've come since our humble GIS and CAD beginnings. So GIS and CAD are still our bread and butter, and we've expanded so much based on the needs of our customers. We now support over 500 formats, standards, and applications. And speaking of bread and butter, we're going to jump into today's topic now. This is part one. We'll be talking about migrating CAD drawings to GIS. I will also mention here that all of the workspaces that Evie and I demo today, they will be available for download when this webinar recording gets posted. So you can feel free to try them out for yourself if you'd like. All right, so I'm going to jump into our first scenario here. This was actually also the first data challenge that SAFE and FME ever tackled, so a bit of history there. And the story here is that we have some forest cover maps that were drawn in MicroStation that we want to use in GIS analysis. The problem was that in MicroStation, these boundaries are represented using lines and points. The points have the attribute data attached to them, but in the GIS, we just wanted the polygons with the attributes. So to do this, we will of course be using FME, in particular our area builder and point on area overlayer transformers, in order to create those areas and then assign them the appropriate attributes. This is the MicroStation specification that we're looking at today. We are looking at levels 9 and 10, with 9 being the lines and 10 being the points, again, where the attribute data comes from. And basically, these are the specs that we will be using to build our areas. And this is what our input data looks like. This is the forest cover map that was drawn in MicroStation. You can see the yellow interior points there. And now I'm going to be showing you how this is done in FME with a little flash demo. So when you open a fresh new workspace, this is what you see. So in the middle here is the canvas where we will be building out our workflow. I'm just going to go and add a MicroStation reader here just by typing on the canvas and then selecting the data that I want to start with. In this case, it's the boundaries and points that we just saw. There they are. I'm going to go hit run on that. And the green magnifying glasses that pop up, those are feature caches. They basically store the data at every step of the translation. It's a really great tool for troubleshooting. And you can easily view the data using our visual preview down here. You've got the graphics and the attribute table right next to each other. Right, so next we're going to add a tester, which is a filtering tool, and I have this one set up already. I'm just going to go and add a summary annotation, which will show us how the parameters were set up. So essentially, we only want features that have an element type of 7 and a graphics group of 0. Next, I'm going to run that tester. And as you can see, 862 features passed, and we'll be using those, and 393 did not pass, and we will not be using those. Next, we are going to add an area builder, which is going to take those forest cover boundaries and fill them in to create areas. I'm going to go run that. And our result will show us that the perimeters have been turned into areas, which is exactly what we wanted. Next, we're going to add a point on area overlayer, and this is going to identify which points are located on which areas, and then join the point attributes to the area. So I'm going to connect our area builder and tester to it, and then we're going to run that as well. And there is our result. We can see that the boundaries have now taken on the attributes of the point layer. And last but not least, we're going to add a shapefile writer here quickly. I know shapefiles are kind of losing popularity, but if you download this workspace to play with, you can feel free to switch it out to anything else. So one of the cool things about FME for sure is that it's easy to edit and swap things out if you need to. So now that that's finished running, we can see our final result. And there it is again. So here's our workspace again. We only needed to use 3 transformers to achieve this. And just to recap the scenario, we took some CAD line work and used a couple of transformers to build areas out of lines. We also made use of the feature caches and visual preview window to keep us on the right track, help make sure our data looks good at every step as we built out this workflow. The key transformers here were the area builder and point on area overlayer. And we also made use of the tester transformer to create a subset of the data that we wanted to work with. We are now left with data that's ready for spatial analysis in the GIS, as well as a workspace that can be tweaked. We can use it over and over again with a new set of forest cover maps. And now I'm going to hand it over to Evie. She's going to be telling you how to change coordinate systems.
Thanks, Sarah. So our scenario 2 is coordinate systems. We'll be going over how to read and set coordinate systems from original CAD files to be able to use in our GIS. Sometimes DWG files don't have coordinate systems, and sometimes they do, and we can rate them. And so we will showcase the coordinate systems available and the result of having them assigned. So the input data here, you can see that there is no coordinate system, there's no background map right now. And so this is what the data looks like. To move on to the demo here, I'm going to drag and drop the file onto the canvas, select the coordinate system in the reader, and load it in. You see here, and then I'm going to run it just to see if the coordinate system has successfully been read in. You can see here that yes, it has been read in successfully. You can see in the visual preview, and I'm going to read it in again without a coordinate system set in the reader, and you'll see the difference here in the visual preview and in the feature information window here. Yeah, there's unknown coordinate system, but I can add a coordinate system setter. I'm typing freely on the canvas and adding it here, and I'm setting it in the coordinate system setter. You can see here all of the coordinate systems available, and yeah, there's lots of coordinate systems available. You can also add your own coordinate system. That's the end of the demo. So this is the solution. It's just set it in the reader or set it in a coordinate system setter after the fact. So if you ever forget and you're just loading it in and press OK too soon, you can always set it later. That's no worries. Yeah, so this recap here, the task was to assign coordinate systems. And the tips for success is that you can set it in the reader. You can use the coordinate system setter to set the coordinate system of your data. You can use the reprojector as well as other coordinate system transformers as well. The reprojector, the difference between the coordinate system setter and the reprojector is that the coordinate system setter sets the coordinate system that already exists, Meanwhile, the reprojector reprojects into a new coordinate system. So you would have to have a coordinate system already set. So like from a local to a projected coordinate system and of the like. You can also write coordinate systems to CAD files. There are some articles here that we can put in the chat. Which AutoCAD format should I use, and getting started with AutoCAD to get you started. So I'll pass it on to Sarah for the next demo.
Okay, thanks. So in this next scenario, we will be moving from labels to attributes with proximity. This is also known as proximity matching. And so here we have some labels that we need to attach to nearby lines, which are streets. So essentially we want to attach street names to streets, and containment is not an option here. So the key transformer for this workspace will be the neighbor finder. This will find the closest geographic match between two sets of spatial data so that we can attach label information to the line closest to it. So here's the CAD label data that we are starting out with. They are even in the right orientation, they just don't have the line data set. So it's not great for spatial analysis the way it is now. And let's look at the workspace that we're going to use to fix that. So this is our roads line data set. You can see there are no attributes attached to it at all. And we're going to join this with the road names CAD file that we just saw. So first we're going to use the text property extractor to extract road names to the attribute table. And there they are. And then next we're going to use that neighbor finder, which will merge them together based on the closest spatial match. So there they are with the appropriate street names. And so now this long road down the middle here, Glover Road, it is one long road, but it's segmented because that's how the lines are in the line data set. And we can just merge them together using this line combiner. So this is going to merge all the lines that have the same street name. And there it is, one long road as it should be. And our last step there was just writing it back out to CAD. So you could see that using simple workspace like this, it's just really easy to attach labels to your data set. You can, of course, add more to it, but this is a great starting point. And so to recap here, we used a neighbor finder to do proximity matching between a set of labels and a line data set. We then used the line combiner to combine lines with the same road names, and this gave us a more realistic picture of how these roads look in the real world. One idea you can use to take this workspace to the next level, you can maybe add a tester after the line combiner. That could be used for QA and just making sure that all the lines were properly combined. Anything that falls through can be investigated manually. You can even add some more transformers to patch them up. Many things you could do here to kind of expand on this workspace. Right, so we've seen a couple demos now, and if you're new here, you might be getting a little overwhelmed with all the transformer names and functions and parameters that we've been throwing around. The good news is that you don't have to remember them all. We have over 500 transformers and counting, and I don't think any one person in the world can remember how to use them all or even just all of them. So this is where we have a transformer gallery. It's really helpful to help you find the transformer you need, and that is available on safe.com/transformers. And it's also built into the FME form canvas. So as you can see on the far left side there, you can also use the quick add feature by clicking on an empty spot in your canvas and typing. You've probably seen us do that a few times now. And on the bottom left-hand corner of any reader, writer, or transformer, there is a help button, and that will take you straight to the documentation. So we really hope that these tools can save you from feeling lost when building your workspace or trying to figure out what transformer you should use next. And with that, I'm going to hand it over to Evie again to show you all how to handle schema drift.
Thanks, Sarah. Yeah, so schema drift, we are going to use regex and AI to go over this next scenario. But what is schema drift? So a change in the source or target data definition is what schema drift is. And this usually is a lot of frustration and causes time loss because it's hard to deal with if you don't have an automatic process to deal with it. But FME can help with this. So we are going to show you a little bit about how to do this with our decode attribute rich layer names in our example. We are going to, this example has been used in the previous webinar. I've changed it slightly to show you an alternative way, but we are going to extract attributes encoded in the CAD layer name to use in GIS. The block is that the comprehensive specification embedded attributes in parts of the layer names, making it very hard to understand or otherwise use the data. So we're going to split these out into parts and make this into an understandable GIS ready data set. So to look at the data, we have here the layer name is 3-character code for the road type, 8 digits for the date of the last update, and 2 characters to represent collection method. So this here is all of the layer names, and we'll go into the demo. So here is the previous workspace. I'm just going to run the reader here, and I will add a new transformer called the string searcher to use regex. So you can see here the data and what it looks like. And I'm just going to type freely on the canvas to add the string searcher, move it a little closer, and connect it up to the reader. If I go in here, I'm going to go to search in the FME feature type and add a regex. I'm going to use the AI assist, the new AI assist method, to put this in plain English. I'm going to extract the 8 consecutive digits here and click on generate. Yes, it's going to use a third party, and here we are. This is what we need, is exactly what we need. I'm going to click apply, close, click OK again, and run it, and let's see if this works. And so it'll go into the first match attribute that I set, and you can see that it has extracted the date. So that's super exciting. I'm going to add another string searcher I already have prepared for you, just over on the side. And this is going to extract the other code so that we can use the rest of this to use the type. Yeah, and we're going to add a attribute value mapper here to the canvas and connect it up to the string searcher and set the second match as our input value and import the values from an Excel spreadsheet. I'm going to select it here. And I'm going to make sure that I'm importing from attribute values, not names, and select the code and what I'm going to be assigning it to and import. And you can see here that the input and output values are assigned. And if I run that, now all of the extracted attributes that from the string searcher are now assigned. So they're looked up and they're there. So now I can connect it to the writer, and this writes to a shapefile disconnected from the previous example, and I can assign the user attributes in the writer here, the type, and assign the attribute here. I want it to be looked up. And press OK. And that's it. So then if I run it, then that's it. That now it's usable in our data. They're now extracted, and it's used. We can use it in our GIS. So that's the end of the demo. So this is the solution here. You can see that I've added the string searcher and attribute value mapper, and this is the alternative to the attribute splitter and database joiner that has a similar outcome. So there's several ways to achieve the same thing in FME, and this is just one way. Yeah. So to recap, the task was to extract attributes encoded in a CAD layer names to use in GIS. We used the attribute splitter in the previous webinar, and now we're using the string searcher to extract values using regex and AI, and to decode the parts using a attribute value mapper. So this is the benefit of using these transformers to route an attribute-rich GIS dataset. So now for the next solution, our scenario here is the digital plan submission. This is an example from the City of Henderson. The City of Henderson wanted to improve their digital plan submission process for new construction projects by simplifying and automating CAD to GIS conversion. Before, all the data entry and processing was done manually, but using FME, they created one automated workflow, which helped reduce data integration time by 75% without impacting the quality of the data. This is still in use today. Land developers use the web portal to submit their drawings and immediately receive an email confirmation or error report through HTML streaming. So the goals and results for this is that for this scenario are to create a digital plan submission, to automatically check and upload CAD drawings to ArcGIS Online. The block is that it takes time and manual effort to process these plans, and now we have automated this process with FME to validate CAD submissions before and automatically uploading them to ArcGIS Online. The result is that the submissions meet the requirements and are uploaded to ArcGIS Online, and the ones that don't are sent back for fixing to the user themselves. So to recap, the task was to create a digital plan submission that checks the validity and either passes the file to upload to ArcGIS Online or fails and returns a streamed report of HTML of why it failed. This provides the submitter with information to fix the file immediately and submit again with no communication wait time, keeping the responsibility back on the submitter to provide valid submissions. At a high level, working from CAD to GIS involves a lot of capturing human readable information and cleaning up topology so the data set can be used for analysis in the future. Some of the transformers we've noted here from the workspace you saw really highlight that process, including the snapper, intersector, area builder, point on area overlayer, and neighbor finder. So I'll pass it on to Sarah for the next part of the webinar.
All right, thanks. So we have arrived to our second and final section. We're just going to shift our focus a little bit to talk about how we can share GIS data with CAD users. So CAD data, as we mentioned at the beginning of this webinar, is very, very visual. So it's just really easy to see what you're doing and looking at when you use things like block instances or symbology to represent objects or to differentiate between areas and textures. So when you're moving from GIS to CAD, it is a challenge to keep those visuals looking nice and easy to interpret while also keeping the intelligence of GIS data. So this might be things like coordinate systems. CAD data also needs to meet certain standards a lot of the time. So like how we saw in the previous CAD validation demo, there are restraints and certain things that need to be structured or stylized properly, and that's why it's important to take care when you're moving from GIS to CAD. And speaking of the importance of styling, our sixth scenario is going to cover that. So in this scenario, we are taking point, line, and polygon data that was meant for GIS, and we are outputting it to CAD. Our challenge here is with the styling specifications that is expected of the CAD file, but luckily we have some styler transformers that will help us with this. So let's take a look at what we're working with. This is the GIS data that we need to transform. We've got the purple park polygons, bike paths, which are represented by the red lines, and dog park set are represented by the pink points. And we're going to take a look at our workspace. This is our input data again on the side. We'll be classifying all these components differently using several DWG stylers. This one's being used to style areas. You can set the color up there as well as a fill pattern. For parks, we're using grass, but there are lots of other options to choose from. We also have a template file added here. This is an optional parameter, but it can be used to define layers, colors, block definitions, and here we're going to be using it for line weights. So there are different options for lines or text styling as well as blocks. So it's pretty simple to apply styling onto your DWG. There is also a DGN styler, which is the MicroStation version of this, and I'll come back to that in a second. And our workspace is run. I'm going to show you the output in AutoCAD. Just looks a little nicer over there. And yes, you can see all the symbology has been applied, and you can use this in AutoCAD now. Here's our workspace again. This workspace actually came from our FME hub, and we're going to stick the link to that in the chat. And if you don't already know about it, I'll do a quick plug here. The hub is a great place to find custom transformers, templates such as this one, and just lots more fun stuff. So another great resource to check out. But back to our demo for now. So we started with features from a file geodatabase, and we used 5 DWG stylers to stylize the types of features differently so that we end up with symbology that is much simpler to understand in CAD, as you can see here. All right, so to recap this demo, we took some GIS data and some DWG stylers to apply symbology. We made use of a CAD template to provide some of the layer definitions, and we did do some minor filtering and labeling just to make our styled output a bit more clear and just more relevant to what we wanted to show. And lastly, as I mentioned, there is also a DGN style if you're working with MicroStation. It works pretty similar to the DWG styler. It kind of does the same thing, but just a little differently. And we have a bonus 7th use case to cap this all off. And this comes to us from the city of Burnaby in British Columbia, Canada. They had a call before you dig system so that land developers can receive information about what's underneath the ground before they dig into it and mess it up. And it's a really great idea. It takes a lot of the guesswork out of the digging. However, the problem they ran into might be considered a good problem, but it was still a big problem nonetheless. The city grew very, very quickly, and as a result, the volume of requests increased by 6,000% over just 2 decades. So you can imagine it was impossible to manually keep up with it all. And this is where they brought in FME to automate that process of procuring and packaging the information. And this cut the wait time from 3 days to a very impressive 3 minutes, which is a huge improvement. The staff there that were previously overwhelmed and probably really stressed by this can now shift their attention to more productive tasks, and by using FME, they eliminated the risk of manual errors. And so with that happy ending, we have arrived at the end of the demo and scenario portion of our webinar, and I'm going to hand it back to Evie and Elizabeth to wrap us up.
Thanks, Sarah. Thanks for joining us on our journey through CAD and GIS integration. We hope today's webinar showed you several ways you can achieve harmony between CAD and GIS by automating its integration. We started the first half of our scenarios of looking at migrating CAD drawings to GIS and some real-world challenges by taking sometimes messy CAD drawings and bringing it into a geospatial environment for possible analysis down the road. In our examples, we showed how to QA or clean up geometry, how to bring text as attributes on corresponding geometry, how to represent CAD elements in GIS to bring all the information across. Using FME to facilitate this integration, we are then able to get the full potential out of our CAD data into an environment that facilitates analysis, enabling sharing of the latest and most up-to-date data among GIS users, decision makers, and planners. In the second half, we looked at sharing GIS data with CAD users, and some of the challenges there were about maintaining georeferencing and representing GIS intelligence through the use of symbology. We looked at how municipalities today use self-serve data requests to get GIS data to those who need it without any wait time and in the format they need it in. So going both ways, FME really helps achieve a harmony between CAD and GIS by automating its integration. So now for some resources. We have tutorials in the FME community. We can put this in the chat. The GIS-to-CAD convert parcel polygons, lines, and geobases to DGN, how to convert DGN to shapefile, CAD levels to GIS attributes, and getting started with AutoCAD and using the geometry parameter in FME Flow. So there's also our ebook, our FME Academy as well, links there, and our knowledge base and more webinars as well on our website. So check those out. So I'll pass it on to Elizabeth for our next steps.
Perfect, thanks Evie. I just dropped those links from the resources slide in the chat there, and I'll take over screen sharing. All right, so some next steps to help you get started. If you are newer to FME or you have any questions related to data, we'd love to chat with you, info@safe.com. If you are new to FME, we encourage you to also check out the FME Accelerator course. It's a 90-minute workshop free of charge, and it'll help you unlock the power of your data. If you are a member of the community, we do have a community badge code for you to redeem today. So I will drop that in the chat here as well. If you aren't yet a part of the FME community, please do check it out. It's a great place to network with other users. It has a lot of great resources, and also you can connect with FME experts there. And with that, we do have about, over 20 minutes remaining for some Q&A, which is awesome. So I'll invite our presenters to come back on with our webcams here, and we can start to take a look through the question panel. And a good tip for the presenters and I will just go to the questions and also sort by upvotes. That'll help us prioritize. But thank you so much, everyone, for all these fantastic questions. I know we did get to quite a few during the webinar, so that's great. Any in particular, Evie and Sarah, we might want to get started with here?
I do want to mention that there was a lot of questions coming in about the AI Assist, and I want to mention that it is available in FME 2023, and it is available in transformers that use regex, that use SQL and Python. So if you look for transformers that use those functions, you can find that feature.
Excellent.
Yeah. But that was the only question that I wanted to really elaborate on. There's so many questions.
Yeah, it's awesome. Thanks, everyone.
I found the documentation for one of them, so I'm just scrolling back to find the question now. It's the one on ProjectWise.
Oh, awesome. Great. Someone was asking about migrating AutoCAD to GIS.
Yeah, so that's something we do really often, CAD to GIS and vice versa. So I guess it kind of depends on how you want to migrate things and what exactly you're trying to migrate. But that's kind of something we do really frequently. So lots of resources online on our website to help you kind of guide through that.
Yeah, I find that it is our most common use case, one of the most common use cases for FME. But I want to stress that it really depends on your AutoCAD file and what your data actually looks like, because it's not a one-fits-all solution. It really does depend on your data.
I see one here on how the neighbor finder can make a decision on which text labels for which line. So the neighbor finder has a base and a candidate port. And so basically the lines are your base and your text labels are your candidates. And so it kind of just matches based on, I guess, the points that the text label is situated on. So you'll just find the closest one. And there are other ways to kind of work around this if you want certain labels, if you want one that's a little bit farther, but typically it just matches based on proximity.
Awesome.
I see a question about, it's more of a specific question about if they have layers that don't follow a naming convention, and they have lots of background mapping that they don't want to include in their GIS, you can filter not only just on layers, but on attribute schema and lots of other attributes that are in your CAD file. So if you have anything that is similar across your files, you can programmatically import those and translate that into GIS. I hope that helps.
There's a question here on uploading content to ProjectWise instead of ArcGIS Online. And we do have a ProjectWise connector. You will need your own credentials, of course, but that should be available for you to connect to, and then you can upload it instead of using an ArcGIS Online like writer. We do have documentation on that. I'll just stick that as kind of the answer to this question. Or I'll just stick it in the chat here if anyone wants to take a look.
Well, here's another question about BIM and GIS integration as a webinar. I know we have other webinars that are to do with not just AutoCAD, but also MicroStation and BIM. So check out our webinars page for previous webinars that we've done. They're all recorded and uploaded. You can rewatch them. Yeah, but we do plan on revisiting a lot of these in the future. So I hope that answers your question.
I know we do have a two-parter on BIM, so that could be of value there. You can just search for the keyword. I just dropped the link there. And I know some folks have asked about workspaces a couple times. I know we will share out those as a resource with our follow-up email, so definitely stay tuned for that. You can test out things yourself as well.
Here's another question about going from CAD to or GIS to CAD, and yes, it can be done. You can write, read and write from GIS and read and write from AutoCAD. So again, it really depends on your data, but this can be done. And yeah, and there's an AutoCAD styler as well to make sure that it's styled correctly and output in the correct template. And we can also write blocks if you have a template.
Yeah, we can also use the DWG styler for this. You might have to play around with it to kind of get the right fonts to match and such, but it should be possible. You should be able to get pretty close using that.
Awesome. And we should have time for a couple more questions, but I will just take this moment to note while our presenters are scanning for the next question to pick. If we don't get to your question, we'll be sure to follow up by email as well. So definitely get to everything when we can.
Someone asked for the BIM two-parter. Found the link here. Sorry, I'll paste that into the chat. This is part 1, and you can go to safe.com/webinars and then go to the on-demand tab and just type in BIM, and you'll be able to access or see some more of our BIM webinars from there.
Here, I have another question that I found. Can you detect the changes into CAD files? Yes, there is a transformer called the change detector. If you load in both of your CAD files, you can select one as the original and one as revised, and it will detect all your changes. You might have to play around with whether or not you're checking the geometry and attributes and which attributes to match on. But I hope that answers your question. Yes, it's possible. There's so many questions, and they keep coming in.
That's great. Clearly a topic with lots of questions and interest, so that's awesome. Yeah, if it's helpful at all, team, we can sort by upvote as well, and then kind of scroll through to the unanswered ones. So yeah, folks, definitely keep upvoting questions. That helps us organize as well.
Here's one that I already kind of answered, but can you write blocks to DWG in the DWG writer? And the answer is yes. You do need a template file with your blocks and the block names there, but all you have to do is create an attribute with AutoCAD _block_name, and then your block name as the attribute value, and it will automatically assign your blocks. Yeah. It's not very straightforward, but it can be done.
There's a question here on grabbing CAD data in PDFs and migrating it to GIS. So I will say that PDF reading is not particularly easy. It can be really tricky because there's just so many different things that can be involved, but it should be possible. I'll stick another link in here for anyone that wants to look, but we do have a couple of transformers that might help. It really depends on kind of what data you're trying to move over and what data you kind of want to keep in there. But while tricky, it is definitely possible. You just have to kind of play around with it quite a bit.
Do we have insight on if there is an ArcGIS map style, or is that something we might have to get back on?
Let me look it up. I'm not sure off the top of my head, so let me just do some quick searching to see if I can find anything. Otherwise, we'll follow up with you for sure.
And I do see another one here that has quite a bit of upvotes. Does the coordinate system setter work for CAD files that are not drawn to scale? Is that something we might have to follow up on, or we know insight on now?
Yes, I can try to answer this right now. Yes, the coordinate system setter does work on CAD files that are not drawn to scale, but you may have to scale it first. We do have a transformer that scales. It's called the scaler. A lot of our transformer names say what they do in the name. Yeah, so you may have to scale it first to the correct what it is, and then coordinate system setter would work on it.
All right.
Here, I have another question here about AI that suggests the best available transformers, and I'm not sure about this specific use case, but we are implementing more AI availability in the software as we're constantly trying to think of new ways to implement. So look forward to that in the future.
And shameless plug, we do have an AI webinar coming up February 15th. So I'll just drop the link to that in the chat as well, if you haven't yet registered.
There's this question on whether civil 3D pressure networks are supported, and I believe they are. So we have the civil 3D reader that you should be able to use, and that should support that.
Any others we have yet to address that we can answer live here today before we wrap up? Thanks everyone for your patience as we scroll through. There's a lot of great questions today. So
there's one question asking for a tutorial on the requirements for setting up self-serve. We do actually have a self-serve module on the FME Academy that you can follow, and I've just pasted it as an answer there. But yeah, the Academy is a really great place to get started. Look for tutorials and such if you kind of are just getting started with FME and kind of have some ideas of what you want to do. Or even if you don't, also a great place to start. So.
Awesome. And yeah, just last call, any others, Evie or Sarah, that we're wanting to pick out to answer live. And like I mentioned, folks, if we haven't gotten to your question, we'll be sure to follow up as well.
Yeah, I'll follow up offline with the ArcGIS map styler question. I'm not too sure myself, but I'll definitely ask around and get you some answers there.
Awesome. And Evie, any on your end?
Yeah. Yeah, there's a question about personal licenses, and we've changed our licensing model. So be sure to contact us to see if what we can do for you for licenses. And yeah, because we have subscriptions and fixed licenses still. So yeah.
Awesome. Any others, team?
Yeah. I think we're pretty good. I think I'll follow up with a lot of the other ones. And yeah.
Okay.
Yeah, thanks everyone for all your questions.
Yeah,
Really
thanks.
appreciate it.
Yeah, excellent. Thanks so much, everyone, for joining us here today, and Evie and Sarah for all your time preparing this content for us today and sharing it with us and answers to those questions. Much appreciated. Awesome. Thanks, everyone. And to our audience as well for joining us today. We appreciate your time. If you do have a brief moment to fill out our webinar survey, I'll drop that link in the chat again here. We really appreciate any feedback. It helps us continually improve upon our program. So we thank you, everyone, and hope you all have a great rest of your day ahead. Bye for now.
Take care. Bye.
Take care. Bye.